In this video, we're going to start the KutaSoftware Infinite Calculus free worksheet definition of the derivative. Now quickly, I'm going to write a couple different notations for using the derivative. But first, let's talk about what the derivative is. So the derivative we can think of as the slope of the tangent line, but as opposed to it being the slope of the tangent line at the given point, it's taken with respect to x. Now, for the instantaneous rate of change, we found the slope of the tangent line. So when we're calculating the value of the slope of the tangent line at a given point, we are actually calculating the derivative at that given point. But as opposed to finding it at a single point, we want to define the derivative with respect to x. So then we can plug in any x value into our derivative equation and see what that instantaneous rate of change is. So the formula is going to look very similar to that of the slope of the tangent line. Now our derivative, if we're in function notation, we're going to have f prime, or the derivative of f of x. And that's going to equal the limit as h approaches 0, and remember h was our change in x, of, this time we're going to say f of x plus h minus f of x all over h, because we're not calculating it at some given point a, we're calculating it for x. Another way we could write this is as the limit of delta x, which is h, as the limit of delta x approaches 0, then f of x plus delta x minus f of x all over delta x. That's also known the limit of delta y over delta x as delta x approaches 0, which is dy dx. So this is the derivative of y with respect to x. It's not dy divided by dx, it's just called dy dx. The derivative of y with respect to x. So that is going to equal f derivative of x. It's just in a slightly different notation. And that difference is, as opposed to using h, we're using delta x. But those values are equivalent. So in numbers 1 through 10, we're going to use the definition of the derivative to find the derivative of each function with respect to x. So when we're given an equation where y equals something, we're going to use the format dy dx. When we're given function notation f of x, we're going to use f prime of x, known as the derivative of f of x. So let's get started with number 1. Now in number 1, we have the equation in terms of y. So we're going to find the derivative of y with respect to x. So that's dy dx. So this is going to equal the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So I'm going to plug in x plus delta x in for x. So I'm going to have the limit as delta x approaches 0 of f of x plus delta x, which is going to be negative 2 times x plus delta x plus 5. That is f of x plus delta x. Now I'm going to subtract f of x, which is going to be subtracting negative 2x plus 5. And this is all over delta x. My next step is going to be to distribute this negative 2. So I'm going to have the limit as delta x approaches 0 of negative 2 times x, which is negative 2x, plus negative 2 times delta x, which is negative 2 times delta x, plus 5, minus a negative 2x, which is the same as adding a positive 2x, and then I'm also subtracting a positive 5. And this is all over delta x. So you'll see that negative 2x plus 2x is 0 and 5 minus 5 is 0. So all I have is negative 2 times delta x over delta x. But if this is all I'm left with, you'll see that delta x cancels out with delta x. But writing this out, I have the limit of negative 2 times delta x over delta x, and delta x will cancel out with delta x, so I'll have the limit of negative 2 as delta x approaches 0, which is simply negative 2. Therefore, the derivative of y with respect to x, dy dx, equals a negative 2. And that's my solution in number 1, using the definition of derivative to find the derivative of each function with respect to x. Let's move on to number 2. So number 2 is in the form of function notation, so I'm going to need to take the derivative of f of x, which is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's plug in our appropriate values. The limit as h approaches 0 of f of x plus h is going to be negative 4 times x plus h. And then we're subtracting 2. That is f of x plus h. Now we're going to subtract f of x, which is simply negative 4x minus 2. And that's all over h. So now I'm going to distribute my negative 4 to the x and to the h, and I'm going to make sure I'm subtracting each of my terms of f of x. So I'm going to have the limit as h approaches 0 of negative 4 times x is negative 4x plus negative 4 times h is negative 4h, and then I'm subtracting 2 from that, and then I'm subtracting negative 4x, which was the same as adding a positive 4x, and then I'm subtracting a negative 2, which is the same as adding a positive 2. And that's all over h. So from this, you can see that negative 4x plus 4x is 0, and negative 2 plus 2 is 0. So I'm left with the limit as h approaches 0 of negative 4h over h. But now you can see that negative 4h divided by h is a negative 4. So I have the limit as h approaches 0 of the constant negative 4, which is negative 4. Therefore, in function notation, my derivative of f of x is equal to negative 4. So that's my answer in number 2. Let's move on to number 3, where we're going to be dealing with an exponent. Number 3, I have the derivative of y with respect to x. That equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So this is going to be the limit as delta x approaches 0 of 4 times x plus delta x squared plus 1, that is f of x plus delta x, and I'm subtracting f of x, which is 4x squared plus 1. And this is all over delta x. So what I'm going to do is simplify. I know that 1 will cancel out with 1 because 1 minus 1 is 0. And expanding out x plus delta x squared, that's equivalent to x plus delta x times x plus delta x. So that's going to be a squared plus 2ab plus b squared. So I'll have the limit as delta x approaches 0 of 4 times x squared plus 2x delta x plus delta x squared. And I'm still subtracting 4x squared from that. And that's all over delta x. So that's going to equal the limit as delta x approaches 0 of, I'm going to distribute the 4 to x squared, 2x delta x, and delta x squared. So I'll have 4x squared plus 4 times 2, which is 8, so that's 8x delta x, plus 4 times delta x squared, which is 4 times delta x squared, and I'm still subtracting 4x squared from that, and this is all over delta x. So you'll be able to see that 4x squared cancels out with 4x squared to leave me with 8x delta x plus 4 delta x squared all over delta x. So I can split up this limit because my terms are added together over the same denominator. So I'll have the limit as delta x approaches 0 of my first term, 8x times delta x over delta x, plus the limit as delta x approaches 0 of 4 times delta x squared all over delta x. Now you'll see that delta x cancels out with delta x, so I'll have the limit of 8x, and one of my delta x's will cancel out with the delta x in the denominator. So I'll have the limit of 4 times delta x as delta x goes to 0. But because I no longer have delta x in my denominator, I can plug in 0 for delta x because it now will be defined, and 4 times 0 is 0. I'm left with the limit of 8x as delta x approaches 0, which is simply 8x. So in number 3, my derivative with respect to x is a positive 8x. And that's my solution in number 3. In number 4, I'm using function notation. So the derivative of f of x, that's going to be the limit as h approaches 0 of negative 3 times x plus h squared plus 4, so this was f of x plus h, minus f of h, which is negative 3x squared plus 4, and then that's all over h. Now right away you can see that 4 is going to cancel out with 4 because that second 4 is subtracted. And x plus h squared is x squared plus 2x h plus h squared. So I'm going to have the limit as h approaches 0 of negative 3 times x squared plus 2xh plus h squared minus a negative 3x squared or plus 3x squared, and this is all over h. My next step, I'm going to be distributing that negative 3 to x squared, 2xh, and h squared. And again, if you don't feel comfortable expanding out that binomial times itself, break that down and write the work out on your worksheet. But continuing on, I'll have the limit as h approaches 0 of negative 3x squared plus negative 3 times 2 is negative 6, and that's multiplied to x and h, plus negative 3 times h squared is negative 3h squared, and then I'm adding that to 3x squared, and that's all over h. So you can see that 3x squared will cancel out with negative 3x squared to leave me with negative 6xh plus negative 3h squared. But I can add these limits together, so writing each of these over that common denominator, I'll have the limit as h approaches 0 of negative 6xh over h plus the limit as h approaches 0 of negative 3h squared over h. Now notice in my first term, my h's cancel out, and in my second term, h squared over h is simply h. So negative 3h. So this will equal the limit as h approaches 0 of negative 6x plus the limit as h approaches 0 of negative 3h. Now I can use direct evaluation or direct substitution, plugging in 0 for h, so I know that this limit will go to 0 because 0 times negative 3 is 0. So I'm left with negative 6x. So my derivative of f of x equals a negative 6x. Now on to something a little more complicated with 3 terms in number 5. In number 5, I'm taking the derivative of y with respect to x, and that's as the limit of delta x approaches 0, I'm going to have f of x plus delta x minus f of x all over delta x. So that's going to be the limit as delta x approaches 0 of f of x plus delta x is going to be negative 4 times x plus delta x squared minus 5 times x plus delta x minus 2. That is f of x plus delta x. And then I'm subtracting f of x, which is negative 4x squared minus 5x minus 2. And that's all over my change in x delta x. Change in y over change in x, and I'm finding the limit. So what I'm going to do is I'm going to expand out x plus delta x squared. That's going to be x plus delta x times x plus delta x. So I'll have the limit as delta x approaches 0 of negative 4 times, the first terms is x squared, plus x times delta x plus x times delta x. That's the outside terms, and the inside terms is going to be 2x times delta x. And then I'm going to add that to my last terms multiplied together, which is delta x times delta x, which is delta x squared. And then I'm going to subtract. Now I'll distribute this 5 to x and delta x. So I'm subtracting 5x and I'm subtracting 5 times delta x, and then I'm subtracting 2. And from that, I'm going to be subtracting each of these terms in f of x. But subtracting a negative 4x squared is the same as adding a positive 4x squared. And then subtracting a negative 5x is the same as adding a positive 5x. And subtracting a negative 2 is the same as adding a positive 2. And remember, this is all over delta x. So you can see I have a couple of terms that will cancel out in my numerator. 5x will cancel out with 5x, and 2 will cancel out with 2. Now I'll distribute my negative 4 to x squared, 2x delta x, and delta x squared. So I'll have the limit as delta x approaches 0 of negative 4x squared plus negative 8x times delta x, because negative 4 times 2 is negative 8, plus negative 4 times delta x squared, and then I'm still subtracting 5 times delta x, and I'm adding that to 4x squared. And that's all over delta x. So now I'm going to have one more term that'll cancel out my numerator. That's negative 4x squared with 4x squared. So now out of my 3 terms, they're all over that same denominator. Now I'm going to split each of those up, but as separate limits. Because those terms are added together, I can take each of those limits and add the limits together. And that's based off of a limit sum rule. So I'm going to have the limit as delta x approaches 0 of negative 8x times delta x over delta x. And then I'm going to add that to the limit as delta x approaches 0 of negative 4 times delta x squared all over delta x. And then I'm subtracting the limit as delta x approaches 0 of 5 times delta x over delta x. From here, you'll be able to see that delta x cancels out with delta x. In my first term, one of my delta x's in my numerator cancels out with the delta x in my denominator of my second term, and my delta x's cancel out in my third term. So I'll have the limit as delta x approaches 0 of negative 8x plus the limit as delta x approaches 0 of negative 4 times delta x minus the limit as delta x approaches 0 of 5. So you can see that as delta x approaches 0, my limit of negative 8x is negative 8x. The limit as delta x approaches 0 of negative 4 times delta x is 0 because I can plug a 0 in for delta x, and 0 times negative 4 is 0. And then the limit as delta x approaches 0 of 5 is 5. And that limit, remember, is subtracted. So dy dx equals negative 8x minus 5. And that's my solution in number 5. And an easy way to avoid subtracting a limit is to add that limit, but make sure that this negative was associated with the 5. Then you would be adding, but subtracting worked in this case because I knew it was going to be a constant. Now on to number 6. So in number 6, we're finding the derivative of y with respect to x. So that's going to be the limit as delta x approaches 0 of f of x plus delta x, which is 3 times x plus delta x squared plus 3 times x plus delta x plus 3. And we're subtracting f of x plus delta x by f of x, which is just 3x squared plus 3x plus 3. And this is all over our change in x, delta x. So I'm going to have the limit as delta x approaches 0 of, well, in my next step, I'm going to distribute my 3 to x and delta x. I'm going to distribute this negative, so I'm going to subtract each of these terms. And I'm also going to expand out x plus delta x squared. So we'll have 3 times x is x squared plus x times delta x plus x times delta x is 2x times delta x. And then delta x times delta x is delta x squared. So if you need help expanding that out, feel free to write it separately and do the first terms, outside terms, inside terms, and last terms. And then we're going to add that to 3 times x plus 3 times delta x plus 3. And then I'm going to subtract 3x squared. I'm going to subtract 3x, and I'm going to subtract 3. And remember, this is all over delta x. Now, there's a lot I can cancel out in the numerator. 3x cancels out with 3x, 3 cancels out with 3, and now I'll rewrite my numerator as the limit as delta x approaches 0 of distributing this 3 to x squared, 2x delta x, and delta x squared. I'll have 3x squared plus 3 times 2 is 6, so that's 6x times delta x plus 3 times delta x squared is 3 delta x squared, and then I'm adding that to 3 times delta x, and then subtracting 3x squared. So you can see that that is all over delta x, and now in my numerator I can cancel out 3x squared with 3x squared. And there's no other terms that I can combine. However, I'm going to split this limit up into 3 separate terms because I'm adding these 3 terms all over the same denominator. So I'm going to have the limit of 6x times delta x over delta x, and that's as delta x approaches 0. And I'm going to add that to the limit of 3 times delta x squared over delta x as delta x approaches 0. And then I can add that to the limit of 3 times delta x over delta x. Now look what cancels out. Delta x cancels out with delta x in my first limit. One of my deltas cancels out in my numerator with the delta from my denominator in my second limit, and delta x also cancels out in my third limit. So I'll have the limit of 6x as delta x approaches 0 plus the limit of 3 times delta x as delta x approaches 0 plus the limit as delta x approaches 0 of 3. Now, 6x and 3 do not have the term delta x within that limit. However, as delta x approaches 0 for my middle term, we can substitute in 0 for delta x, and 0 times 3 is 0. So my derivative with respect to x, dy dx, is going to be 6x plus 3. And that's my solution in number 6. Let's move on to number 7. So in number 7, we're finding the derivative of y with respect to x, dy dx. And that's going to equal the limit as delta x approaches 0 of f of x plus delta x. So that's going to be the square root of negative 3 times x plus delta x minus 5 minus negative 3x minus 5, and that's all over delta x. F of x plus delta x minus f of x all over delta x, and it's the limit of that as x approaches 0. Now what I'm going to do in order to simplify, I'm going to multiply by the numerator's conjugate over itself. So essentially I'm multiplying by a value of 1. So I'll have the square root of negative 3 times x plus delta x minus 5 plus, because the conjugate, we're switching this sign, the square root of negative 3x minus 5, and that's all over the conjugate, which, rewriting that, negative 3 times x plus delta x minus 5 plus the square root of negative 3x minus 5. Now, I multiply by the conjugate because think about multiplying a minus b times a plus b. That's going to leave you with a squared minus b squared. So when FOILing, we only need to pay attention to the first terms times the last terms because the inside and outside terms will cancel each other out. So I'll have the limit as delta x approaches 0 of my first terms multiplied together will be that term squared, which will give me negative 3 times x plus delta x minus 5. And then I'll be subtracting my last two terms squared, which will be negative 3x minus 5. And that's all over delta x times that conjugate, the square root of negative 3 times x plus delta x minus 5 plus the square root of negative 3x minus 5. Now look, when I take negative 3 and multiply that to x, I'll get negative 3x. And I'll be adding that to negative 3 times delta x. However, you'll see that that negative 3x cancels out when I subtract another negative 3x, because negative 3x minus negative 3x is 0. And then I have negative 5, and I'm subtracting a negative 5, so that will be 0. So the only term I have remaining in my numerator is negative 3 times delta x. So I'll have the limit as delta x approaches 0 of negative 3 times delta x, and that's all over delta x times the conjugate, the square root of negative 3 times x plus delta x minus 5 plus the square root of negative 3x minus 5. But look, delta x cancels out with delta x. And because I no longer have a value that will give me 0 in the denominator, I can use direct substitution, plugging in 0 for delta x to solve. So I'll have negative 3 all over the square root of negative 3 times x, because x plus 0 is x, and negative 3 times x is negative 3x, minus 5, and I'm adding that to the square root of negative 3x minus 5. And since I'm adding that to itself, I'm going to have 2 of those. So my derivative of y with respect to x is going to equal negative 3 over 2 times the square root of negative 3x minus 5. So dy dx equals negative 3 all over 2 times the square root of negative 3x minus 5. Now let's continue on to number 8. In number 8, I'm finding the derivative in function notation. So the derivative of f of x is going to equal the limit as h approaches 0 of f of x plus h, which is the square root of 4 times x plus h minus 5 minus f of x, which is the square root of 4 times x minus 5, and that's all over h. Now, how I'm going to simplify this is I'm going to multiply by the conjugate over the conjugate, and that's the conjugate of that numerator. So I'm going to multiply by the square root of 4 times x plus h minus 5 plus, because the conjugate, as opposed to subtracting, I need to add the square root of 4x minus 5. And that's all over the conjugate, because the conjugate divided by the conjugate is 1, and multiplying it by a value of 1 does not change the overall value, it just helps us manipulate the expressions. So, rewriting that conjugate, 4 over x plus h minus 5 plus the square root of 4x minus 5. Now, when multiplying by the conjugate, you can think of that as a minus b times a plus b, which is going to be a squared minus b squared. So when foiling, those outside and inside terms will cancel each other out. So we just need to multiply the first terms and the last terms. So we're going to have the limit as h approaches 0 of the square root of 4 times x plus h minus 5 squared. So that's going to be 4 times x plus h minus 5, and we're going to be subtracting the square root of 4x minus 5 squared, because it's multiplied by itself. So that's 4x minus 5. And this is all over the conjugate, which is the square root of 4 times x plus h minus 5 plus the square root of 4x minus 5. And that conjugate is multiplied by h. So now I can cancel out quite a few terms in my numerator. When I multiply 4 to x and 4 to h, I get 4x plus 4h. But note that that 4x will cancel out with 4x later because 4x minus 4x is 0. And if I have a negative 5 and I'm subtracting a negative 5, that's negative 5 plus 5, which is also 0. So the only thing remaining in my numerator is 4h, and in my denominator, I'll have h times that conjugate, or the conjugate times h, which is the square root of 4 times x plus h minus 5 plus the square root of 4x minus 5. And this is still evaluated as the limit of h approaches 0. But look, now I can cancel out h with h. So I no longer have a 0 when I plug 0 in for h in my denominator. So I can now solve. So I'll have 4 all over the square root of 4 times x plus h, but remember h is going towards 0, so plugging in 0 for h, I'll get 4 times x plus 0, which is 4 times x. So the square root of 4 times x minus 5 plus the square root of 4 times x minus 5. Simplifying, that will be 4 all over 2 times the square root of 4x minus 5, because 1 times the square root of 4x minus 5 plus 1 times the square root of 4x minus 5 is 2 times the square root of 4x minus 5. And 4 divided by 2 is 2. So I'll have 2 in my numerator and the square root of 4x minus 5 in my denominator. So the derivative of f of x, f prime of x, equals 2 over the square root of 4x minus 5. Now on to number 9. In number 9, we're finding the derivative with respect to x. So dy dx. That's going to be the limit as delta x, or dx, approaches 0. So I'll have 1 all over x plus delta x plus 2, and I'll be subtracting 1 over x plus 2, that's f of x, so f of x plus delta x minus f of x all over delta x. So in order to solve, I need to combine those terms within my numerator. Therefore, I need to have them with a common denominator. So I'm going to multiply my first fraction by the second denominator over itself, multiplying it by 1, and then I'm going to multiply my second fraction by the first fraction's denominator over itself, multiplying that fraction by the same value 1, but using different numbers. So I'll have x plus 2 over x plus 2, 1, times 1 over x plus delta x plus 2. And then I'm going to be subtracting x plus delta x plus 2 all over x plus delta x plus 2 times 1 over x plus 2. And this is all over delta x. And this is still the limit. So this is the limit as delta x approaches 0. Now I'll combine those all over the same denominator, because when I multiply this out, x plus 2 times x plus delta x plus 2 is equivalent to x plus delta x plus 2 times x plus 2. Therefore, I can subtract those numerators. But I'll just write this all out again. So I have the limit as delta x approaches 0 of, first we're going to do x plus 2 times 1, which is simply x plus 2. And then I'm going to be subtracting x plus delta x plus 2 times 1. So that's just going to be x plus delta x plus 2. And this is all over x plus 2 times x plus delta x plus 2. Now that I've taken care of my numerator, I cannot forget that that's all over my denominator of delta x. So, simplifying this, x minus x is 0, and 2 minus 2 is 0. So I'll have the limit as delta x approaches 0 of negative delta x. And that's all over x plus 2 times x plus delta x plus 2, and then that entire quantity is divided by delta x. However, as opposed to dividing by delta x, just so you can see this visually, I'll multiply by 1 over delta x. So negative delta x divided by delta x is a negative 1. And now I'll have the limit of negative 1 over x plus 2 times x plus delta x plus 2 as delta x approaches 0. And now I can use direct substitution or direct evaluation, plugging 0 in for delta x. So that's going to be negative 1 all over x plus 2 times x plus 2, which, expanding out my denominator, is going to give me negative 1 all over, first outside, inside, last, x squared plus 2x plus 2x plus 4. Therefore, in number 9, my derivative of y with respect to x equals negative 1 over x squared plus 4x plus 4. And that's my solution in number 9. Now let's continue on to number 10. So number 10, function notation. So we're going to find the derivative of f of x. So the limit as h approaches 0 of f of x plus h, which is going to be negative 2 over 2 times x plus h, and that's going to be minus 1 minus f of x, which is negative, so subtracting a negative is the same as adding a positive, 2 over 2x minus 1, and that's all over h. Now, in order to combine my numerator, I'll need a common denominator among those fractions, and how I get that is by multiplying the first fraction by the second denominator over itself, which would equal 1, and then multiplying the second fraction by that first denominator over itself. So you'll see that I'll have the limit as h approaches 0 of, and as opposed to writing that all over h, I'm just going to write 1 over h times that quantity because it's the same thing. And that's going to be 2x minus 1 over 2x minus 1 times this first fraction, negative 2 over 2 times x plus h minus 1, and then I'm going to be adding 2 times x plus h minus 1 over 2 times x plus h minus 1. So you can see that this equals 1 times my second fraction, 2 over 2x minus 1. Now I'm going to simplify. So I'll have the limit as h approaches 0 of 1 over h times, I'm going to distribute this negative 2 to 2x and to 1. So that's going to be negative 4x plus 2, and then I'm going to be adding that to 2 times 2 times x plus h, and 2 times 1. So 2 times 2 is 4, so that's going to be 4 times x plus h, and then 2 times 1 is 2, so minus 2. And that's all over our common denominator, because I was able to add those because they now have the same denominator, which is 2x minus 1 times 2 times x plus h minus 1. And I just want to iterate the fact that we're multiplying these denominators together, so this needs to go in parentheses. And now you can see we can simplify. 2 will cancel out with negative 2, so I'll have the limit as h approaches 0 of 1 over h times negative 4x. Now I'll go ahead and also distribute 4 to x and h, so that's going to be negative 4x plus 4h, and that's all over our denominator of 2x minus 1 times 2 times x plus h minus 1. Now I can simplify my numerator even further. So I'll have the limit as h approaches 0 of 1 over h times negative 4x cancels out with 4x. So that's just going to be 4h over 2x minus 1 times 2 times x plus h minus 1. And now you can see that I can finally cancel out my h from that denominator. And then that limit will now allow me to plug 0 in for h. So in doing that, I'll get 4 over 2x minus 1 times, remember, this h is approaching 0, so if this h is approaching 0, x plus 0, so then that's 2x minus 1. Again, that's because this h is getting closer to 0. And now expanding my denominator, I'll do first, outside, inside, last. So that's going to be 4 over 2x times 2x is 4x squared, plus 2x times negative 1 is negative 2x, plus negative 1 times 2x is negative 2x, and then I'm adding negative 1 times negative 1, which is a positive 1. So the derivative of f of x equals 4 over 4x squared minus 4x plus 1. And that was just combining my like terms in the denominator to solve. And that was the answer in number 10. So for our critical thinking question, it says use the definition of the derivative to show that the derivative of f of 0 does not exist where f of x equals the absolute value of x. So using the definition of derivative, we're going to say that the derivative of f of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. But we're using f of x as the absolute value, and x we're given is equal to 0. So we're going to have that the limit as h approaches 0 is equal to f of 0 plus h minus f of 0 all over h. So that's going to be the limit as h approaches 0 of f of 0 plus h is going to be the absolute value of h, because 0 plus h is h, and then we're subtracting f of 0, the absolute value of 0, and that's all over h. But notice that when we're subtracting the absolute value of 0, that's just 0. So we're going to have the absolute value of h over h, and we're finding the limit of this as h approaches 0, which is technically undefined, because we cannot have a 0 in the denominator. So using 0 in the definition, we get the limit as h approaches 0 of the absolute value of h over h. But that limit does not exist because as we approach 0 from the right, we're going to have a positive value over that same positive value, which is going to be a positive 1. And as we approach 0 from the left, that's going to be a positive value over that same value, but negative. So that's going to be a negative 1 for the limit. So because 1 does not equal negative 1, the limit of the absolute value of h over h as h approaches 0 does not exist. So we have this limit, which does not exist. And that limit does not exist because the left-handed and right-handed limits are different. And that's the final solution on this worksheet. Before continuing on to any other worksheet or lesson, please remember to like, subscribe, and share. All likes and subscriptions are greatly appreciated, and just let me know that you're finding these videos useful. Also, if you want another way to support me, become a patron. Make a pledge on my Patreon page, which I'll leave a link in the description below. And if you want more information, go to maemap.com, maemap.com.